All right, welcome back. We're still talking about equilibrium. Remember, equilibrium is basically when the concentration of the reactants and the concentration of the products stops changing in a chemical reaction. And you can see this if you plot the information. You can see this if you plot the information on a graph. So on this particular graph, what they're plotting is how much time went by since the reaction started on the x-axis, and on the y-axis they're plotting the concentration of the different reactants and products in this chemical reaction. So in this chemical reaction we have water and carbon monoxide. They are reactants, and they produce hydrogen gas and carbon dioxide. Those are the products. And they want to keep things relatively simple, so pretend you have a container like a test tube here, and at the beginning of the experiment you have a bunch of water and you have a bunch of carbon monoxide bouncing around in there. So you have a bunch of reactants, which means the concentration of the reactants is high. You're up here when no time has gone by. That's the beginning of the chemical reaction. And you have no H2 and you have no CO2. So the concentration of those things is 0, and that's shown with the blue line here. So with this blue line, at the beginning, when time is 0, no time has gone by, the concentration of carbon dioxide and hydrogen gas, they're basically 0. So you have a lot of reactant and you have no product. And if you wait around a while, the concentration of the reactant starts to go down, down and down and down, because the stuff on the left side of the arrow, the reactants, is being converted into stuff on the right side of the arrow. So this stuff is disappearing, which means the concentration is going down. And this stuff is appearing, which means its concentration is going to go up. You are at equilibrium when the concentrations stop changing. In other words, you're at equilibrium on these flat parts of the lines. And that's why it says equilibrium there. So this is one way. If I showed you a graph like this, and I said, where are you at equilibrium? You would look for the parts of the graph where the concentrations stop changing. In other words, where the concentrations are flat as time goes by. There's another way of thinking about equilibrium, and that's shown on this slide. This graph looks very similar to the one that you saw on the previous slide, but it's not. On the x-axis, it has time, just like we had on the previous slide. But on the y-axis, on the previous slide, we had concentration. But on this slide, on this particular graph, we have the speed of the reaction. And what they're saying is the speed of the forward reaction, whenever the speed of the forward reaction is the same as the speed of the backwards reaction, that means you're at equilibrium. So in the previous slide, the chemical reaction was H2O plus carbon monoxide makes CO2 plus H2 gas. And what they're saying is the speed of this reaction going forward is a certain amount. And if you look at the beginning, at when no time has gone by, at the beginning of the chemical reaction, the speed of the forward reaction, that's going this way, is pretty high. And since there is none of this stuff to go backwards, the speed of the backwards reaction is 0 because nothing's being converted. But what happens as time goes by is the speed of the forward reaction gets slower and slower and slower, and as this stuff accumulates, some of it starts to go backwards, which means the speed of the backwards reaction starts to get higher and higher and higher. And you are at equilibrium when the speed of the forward reaction equals the speed of the backwards reaction, because once they equal each other, then you're not gonna end up changing the concentration of anything on the left side or the right side of the arrow. So another way of thinking about when you're at equilibrium is when the speed of the forward reaction and the backwards reaction equal each other. And that would be here because, well, they merge at that point, right? The forward reaction and backward reaction speeds are identical to each other there because you only see one line. So that is the end of this video as far as describing equilibrium. In the next video, there's going to be some math.